Almighty God, we thank you for the gift of life. We thank you for the gift of this new day and for the gift of this lesson. We are here presenting our first lesson for A level into your hands, so that whatever we are taught about, we grasp it and keep it in our heads to be used for future reference. In Christ Jesus we pray. Amen.
Amen. Thank you so much for the word of prayer. I'm not going to restrict some features because I may want you to speak, but still, please make sure you maintain discipline in the room. In case there is anything you want to say, always ask or be organized such that you don't have any poor background noise. So Galax, kindly mute yourself such that we don't have any poor background noise. I'm going to first share with you, mainly since people here are for submath. I know there are people who have joined in who are not submath students. It is okay. Don't mind. Don't mind. You are going to pick something from the lesson. Those who are from senior 5, don't mind. You are going also to learn something in probability. Now, last year your friends did a submath, but one thing I want to start with that there is nothing that is very small. The one point you may look at may deter you from achieving your dream course. So you may look at submath as having just one point, but this 1 point, allow me now to mute. I think this galaxy is okay. Yes, you may look at the 1 point as something very small, but that 1 point has a weight. It can move you from doing your course. Let me say you want to do law, and it can push you to do social science because of just 1 point. It has a weight. So for anything you do in submath, make sure you aim at getting that point, whether you have scored your 50, 60, as long as you have the point on it. But also in the future, when you are advancing, mainly those people are going, some people may go outside of the country, always they need some background of mathematics. Many of the courses outside, they need a background of mathematics. So you having a good mark puts you on an advantage over someone who didn't have that mark. For instance, in order for you to be admitted to Oxford or to those universities in law, they need you to have gotten a good point in math. And now in our Uganda, it is always equated to the sub-math for those people who didn't do math at A level. So for anything you do, kindly do it very seriously. So I know now you know that our paper is always for 240 minutes. But one thing I want to emphasize is that now we no longer have mechanics in what? In our submath. So we have those questions that are a bit simple, but not as simple for those people who have not practiced. Yes, Austin? Austin, what do you have to say?
So I was asking, what about guys of sub-ICT?
Sub-ICT use the second link. There is a link in the class. That link I've shared in the chat. Use that link I've shared in the chat. Okay. So that is how the paper your friends did. So I want you to look through, use your eyes, look through, ask yourself, what if I was the one sitting? Would I have passed this paper? So I'm scrolling a bit such that you may also reflect on it and then ask yourself whether you can be able to pass the paper. So I'm going to scroll and then look through the numbers. I know there are some topics you have not yet covered. Take a mark on those to put a point that we have not yet covered this, but I will make sure I revise it. So that's how your friend's paper was looking like. You can really notice that it was not that an easy paper for someone who had not prepared. Okay. Okay. Hope now you are seeing. Now, when it comes to section B, I think now you have 4 numbers to attempt, and now the 4 numbers you have to attempt, 4 of these questions, you choose 4 questions from this section, but you must make sure at least you pick 1 number from each of the section. So look at the pure math and ask yourself, will I be able to do, if at all I was the one sitting, could I have done this number? Yes, I know some of these topics you have already completed. So look through briefly. So that is how your paper, your friends did. So this is the statistics. That is the statistics. Yes, I want you to comment in the chat. In case you were the one sitting, which grade do you think you would have obtained? Just write in the chat. Just be sincere to yourself that maybe I would have gotten. Use distinctions, maybe distinction 1, 2, credit E. So you just type in the chat. Type in the chat what you think in case you were the one doing this paper. What you think you would have scored. Let me check. Okay, Faith is saying at least a credit 5. What about the rest? Be sincere to yourself. But if you are the one doing the paper, yeah. Someone saying D1, D2. Okay. At least that is good. C3, C5. Okay. This is so promising. This is very promising. D2, C5. Yes. Remember, our target is to make sure that at least you get you run away with a point in math. Okay. At least this is very good. It shows that really you are doing. Yeah. At least when you look at the marks, yeah, they are really promising. D1, credit 3, honestly 50 from Maths Bay. Yeah, that is good. The good thing with the 50, at least you have a point. Good, good, good. Yeah, yeah, yeah. Okay, okay. That is very good. Yeah, and we shall pray to God. We shall pray that at least every one of you at least goes away with a point when it comes to sub math, such that you know now you have more 19 points to work for. Okay, now I'm going to stop sharing this screen and then we start on our topic of probability. Now, the topic we are going to look at is called probability. I know some of you, probably you may have covered it. Some of you, you may not have covered the topic, but it is okay. Those who covered, that is very good. Those who have not yet covered, we are going to learn together. But what do I want to emphasize? When you look at this paper of submath, these numbers you are seeing, I want to show you the number of probability. When you look at now, Okay, sorry about that. Something happened. I'm going to ask the person called Zoom something. Kindly be fair, don't end the meeting and don't place anything. Okay, so I was still telling you that those are some of the numbers. Another number for probability, this is the number, still it falls under probability and it has 5 marks. Still, when I continue, I'll find another probability number is here, which is still 5 marks. So when you look at this paper of sub-math of last year, it had 25 marks. These are 10. And then in this section of statistics, there was a full number about probability. Those are 25 marks. So meaning that this section of probability is very, very important. Those of ICT, please use that link in the chat. So this point, part of probability is very important. So we are going to do our best to ensure that at least we understand the topic of probability such that we can be able to maximize in that section. Allow me now to start the topic. Now, our topic today is called probability theory. So when they talk about probability, probability is that branch of mathematics that is concerned with prediction or uncertainties. And how did it come into existence? Probability came in from things of games, things of gambling. That's where that probability started from. So it came from tossing coins, rolling off the die, playing of cards. So from that one, that's how people came to introduce this kind of topic of mathematics we call probability. So probability, like I've told you, it is about predicting what may happen. It's like now looking at your marks that you have said, I can predict that depending on this student's efforts, this student will be capable of scoring a distinction 1 in math. So it is about predicting what can happen, that depending on the weather conditions, I think today it may rain. Depending on this, so you are not sure of what is going to happen. So whenever you are not sure of something not happening, we have two things. We have two digits. So probability, your answers will always be from 0 to 1. So any number you calculate in the probability, your answer is going to be 0 to 1. We don't have any probability that is above 1. We don't have any probability that is below 0. So whenever you are making your calculations and you come up with a negative 0 point something or negative probability, just know that one is not possible. Still, you cannot have probability above 1. So you come up, you get an answer as 1.5, then mark yourself that there is a mistake I have made. The moment you get anything above 1, know there is a mistake you have made. Anytime you get anything below 0, it also shows that there is an error in your working. So please go back and revisit it. So when you get a probability of 0, this is an assurance that you are very sure something cannot happen. Take an example. You are very sure that you cannot go back to school today. That one I'm very sure. None of you can go back to school today. So that one is impossible. It cannot happen. So that means that the probability of you going to school today, I will say probability is 0. So the letter P is the one that stands for the probability. So when I write probability of 0, this one I'm sure today you are not going back to school. When I get probability of 1, probability of 1 is an assurance that you are very sure you are probability of 1. So probability of 1, that one means you are sure something will happen. What I'm very sure of, that all of you come 5th, you are going to be at your schools. That one I'm very sure. So that is when you are sure of something happening. I'm very sure that all of you today have eaten something, or you have taken some water or what. So that one is an assurance that something has happened, something will happen. So the moment you get your probability as a 1, it means that you are very sure something has happened, something will happen. I'm very sure that you will sit for your exams, God willing. that nothing happens on the way. So that is an assurance that something is going to happen. When you look at the clouds, at times you can get sure that it is going to rain. But what I'm very sure of, that every day, either that once a day comes, we shall always have a night. Kindly respond. I want you to use the chat to type in whether we're on the same page, whether you are understanding what we are talking about. Just type in the chat, say yes or no. Or I can, let me allow you to unmute. Feel free to unmute and tell us whether we're on the same page. Yes, Calvin, it is very okay. Calvin, it is very okay, you stay here. Okay, okay. So depending, people are telling me we're on the same page. Okay, now, yes, okay. Now you write your heading as probability theory. That one should be your heading. That one should be your heading. Median, use that link in the chat to join ICT. Okay, so hope everyone has written probability theory. And now I'm going to ask you to first summarize that page. Summarize that page in your book. So we are summarizing. When you finish, you let us know. Okay, King of Spades. Now, probability is set in applied mathematics. It is set in applied mathematics. Whether you do pure math or you do some math, this topic is vital. It is there. So, but it is in applied mathematics. When you finish, you can let us know in the chat by typing "I've finished." Since people have finished, we give more 2 minutes. We give just more 2 minutes. Those who are still writing to finish. And now those who are writing and we may leave you, you just take a screenshot such that you are safe. Even if we have moved on, but when you have that screenshot. Okay, so we are going to move on. Now, there is something we call a sample space. So when we talk about a sample space means all the possible outcomes. The possible outcomes, it means that what you expect to obtain when you carry on an experiment. Take an example. An example, I'm going to give you a coin. No, I can give you a coin, no problem. When you look at a coin has two sides. It has one side. Let me use, I think, is it one? I need to be. There is a coin where you find a head of a cow, I think, or there is a cow. Then there is and behind there is a coat of arm. So when you throw your coin upwards or in air, when it comes back, you can either get this side, which has a head of a cow, or you can get this side where there is a coat of arm. And where there is a coat of arm is what we call a tail. So here there are only two possible things you can get. You can either get a head or you can get a tail. When we are looking at a day can either be when you look at a day, you can have day or night. When you are playing cards or when you go for a field, when you go in the field to play, let me ask you, when you go in the field to play, what are the possible outcomes you expect from the game? Feel free to raise up your hand and you tell us. When you go to the field to play, what are you expecting? What are the possible outcomes that can result when you go as a team? You are going to play for your team. What do you expect? Any idea? Let me look at the chat. Zoom is telling us a win or a loss. Good. Win, loss, or draw. Thank you, Miriam. Win or loss or draw. Perfect. So now those things that we are expecting to obtain are what we call a sample space. So when you go in the field to play, you can either win, you can have a draw, or you can lose the game. So those are the possible things we expect, nothing else. Now let me ask those people. Okay, perfect. So that is what is going to happen. Very good. So whenever we are doing with our probability, always, now like let me use a coin. Now when you look at a coin, there are two things that we are expecting. Either, let me use the soccer. You can either win, you can lose, or you can draw. Now, when you look, this is our sample space. Now, from our sample space, we can ask ourselves, how many numbers, how many chances, how many opportunities do we have in our sample space? Meaning that the number of sample spaces are win, lose, or draw. So it is equal to 3. Now, when they ask you, what is the probability of you winning the game? So the probability of you winning the game is equal to the number of events. How many chances you have to win the game? That winning is 1. So I will say 1 out of 3. So that is the probability that you can win a game. Hope we are together. So let us continue. Let us continue. We can first write again here. When you finish, you let me. Yes, King. Okay. Part 2 people are finished. You can wait for the rest. Okay. I think we have finished. Good. Now, like I've told you that when we are noting the probability that something has occurred, whenever you find a P, it means probability. Now, any letter you find in the inside is the one that describes the event that is taking place. So when I find A, it means the probability of A occurring. So when I want to say the probability of everyone here getting a distinction, I write it like this: probability that everyone is going to get a distinction. When I want to write probability of winning, I write probability W. So W is standing for winning, that everyone here will win. Now, when I want to represent that something, that probability of going to school, I write probability of going. I write G, probability of going to school. And you are going to notice that here we usually use capital letters only. So G stands for going to school. So when I want to say that you are not going to school mathematically, I'm going to write probability of not going to school. So not going to school, I will not write a word, but I'm going to just put a dash up here. So I write G stands for going to school. When you find a dash, it means you are not going to school. If I don't use that one, I'm going to use this symbol, G, then a prime. So this one means you are not going to school. So whenever you find a prime or you find a dash, it means not occurring. Something is not going to take place. That is the meaning. So whenever you find those two signs, please make sure you interpret them that. At times they can use this one, at times they can use this one, but all of them very okay. In case I want to refer to this in terms of using sets, you remember your sets. I can say in this class, this is my set A with people who have iPhones. So anyone with iPhones is inside this set, which I'm calling A. So when I want to represent people without iPhones, I will say probability of A, then I put a dash, that these are people without iPhones. People without smartphones, that is A prime. Hope we are together on that. Are we together, dear students? You can unmute and tell us.
Yes, sir.
Okay. Is everyone fine with that? We continue. Okay, let me hope so. Now we are going to go to the other one. Now, like I told you, that when it comes to probability, our maximum is a 1. That is the greatest value you can ever obtain. Now, what does it mean? We have said that probability of something occurring, let me say A, plus probability of something not occurring, the answer is equal to 1. For any probability, let me say, probability of you going to school is equal to 0.5. The probability that you are not going to go to school is also going to be 0.5. So whenever you add the probability that something is occurring plus probability that something is not occurring, always we end up with 1 as our maximum. So that one is very important. And this one is our first rule or our first rule. So this is very important. This is an important law whenever we come to probabilities. In some books, you'll find them writing A plus probability of A prime is equal to 1. So here you are going to be playing with the mathematics. At times, they may give you probability that something is not going to occur, and they want you to find probability that something is occurring. So that one, do not always fight with it. Just do the mathematics. You remember our mathematics that when I have x plus 2 is equal to 3, in order for me to get x, I'll remove that 2. And since 2 is positive, I will say x plus 2 minus 2 is equal to 3 minus 2. So my x is equal to 1. So the same thing you do here in algebra is the same thing you do in probability. When they ask you to get probability of A, remove this A prime. When they tell you to get prime A, remove this one. So I will just say probability of A plus probability of A prime minus probability of A prime is equal to 1 minus probability of A prime. Meaning that probability of A prime minus probability of A prime is 0. So probability of A will equal to 1 minus probability of A prime. So you are going to be playing with the mathematics such that you form one another. When I want to compare it in sets, when you take it to sets, in sets, when I have an event here, A, this is my probability of A. Anything outside here is what we call, the red one is what we call probability of A prime. But anything in probabilities from today onwards, know that the number inside will always equal to 1. That the summation of all probabilities within a set always is equal to 1. Kindly let me know whether we are on the same page. Mass is saying we're on the same page. Rodris is saying we're on the same page. I want to find out from the rest. Bogere saying we're on the same page. Yes, people are saying we're on the same page. Okay. Good. Okay, I think we're on the same page. Okay, good. Okay. I think we can now move on. When you have a challenge, you let me know. Okay. Now first make some notes on that. When you finish, you let us know. Everest. Okay. So let's give more 3 minutes such that people can join. Okay, looking in the chat.
I think we can continue.
That's saying we can continue. Okay, now we are going to look at the most important thing. So the next thing we are going to look at is what is very important. And I'll ask you to be very, very, I don't even know how I can call it. Pay attention to that. Once you master that, it is going to be an assurance that we have understood probability. But the moment we don't, then we shall not have done anything. It is like the basis for everything, what we are looking at. Now here, allow me, I'm going to share a white screen, and I want you are going to just let me know whether that screen is there. Are you seeing a whiteboard?
Yes.
Yes, we can see it.
Okay. Now I'm going to first remind you, we did some sets in O level. Now, when I have a set, I want to first see, this is one set, this is another set. I'm going to put letters and I want to see whether people remember. I want people to tell me what name do we give to this part I've shaded? This part we have shaded.
Intersection part.
Intersection. Is everyone remembering that?
Yes, sir.
Yes. So where the two sets meet is what you call the intersection. Then, so this is intersection. Then I'm going to do another part. I'm going to shade this. How do we call that?
That is the union.
The union. So union means you have come together, everyone. I think you have heard people saying, we have a reunion. Okay? So it's like you are uniting. So everything, you bring it together. Now, mathematically, an intersection will represent it with N. So whenever you find a capital N, it means an intersection. When you find a U means a union. Are we together? Is that okay?
Yes.
Now I'm labeling this to be set A, this one to be B, this one to be A, and this one to be. Now, since this one is an intersection, mathematically write A intersection. Is that okay, members?
Yes, sir.
And then here I write A union B. Kindly let me know whether you understood those two concepts.
Yes. Understood.
We have understood, eh?
Yes.
We continue? Okay. Members, should we continue now? Okay.
Yes.
Okay, we are continuing. Now, after that, I want to see whether members are still remembering. I'm going to come. Sure. I have my two sets. I have another set. I'm going to shade something and I want us to use the chart. You type in what you think. This is A and this is B. So I'm shading this. How do we call that point? How do you call that set?
Set A.
Set A. Very good. So that is set A. Set A. Good. Now I'm drawing another one. Still, this is A. How do we call that one?
Set A only.
Perfect. Perfect. Yes, now we are coming. We are coming. So this one, we called it set A. This one, we call it set A only. Now, are you noticing that here, this set A doesn't have B, not so? Is that okay?
Yes,
Now,
sir.
how am I going to write it mathematically? You are noticing that the region, remember this is B. You are noticing that here we have two sets that are combining. But when you look at them very well, you are noticing that I'm only taking A and there is nothing like B. So how do I write it mathematically? I will say set A is intersecting with set B. Is that true? Are they intersecting? Are they intersecting?
No.
They are not. No, like when you look at this is set A and this is set B. They are meeting. However, you are noticing that set B is not part of the shaded part. So to show that it's not part, I'm going to come and I put an arrow here up. So this one is what means that it is set A only without B. Have you got that?
Yes.
Is that okay? Or you can write A intersection B line. So this one shows you it is set A only. Have we got that?
Yes, sir.
Okay.
Yes.
We continue?
Yes, sir.
Yes, you can
Yes.
continue.
Okay, I go to another one. This one, I want you people also to write for me. Use the chart to write for me how we call this one. This is A and this is B. Tell me how we can call this shaded part mathematically. You can type in the chat and I look at your answers.
A complement intersection B.
Okay, B only. So someone mentioned A complement intersection B. Do we agree, members? B only. Or what you call B only. Do we agree?
Yes.
Then I have another one. So we are going step by step because there is something we are building. I have this one. Now I want members to tell me, what about this? When I shade this, everything here, we call this one what? Because this is A and this is B.
A union B.
Very good. A union B. Now I'm coming again. A union B. Now I'm shading here outside. We have these people who don't offer sub-math, they don't offer any. How do we call these people outside?
A union B complement.
B complement.
A union B complement. Is that okay?
Yes, sir.
Yes. So now I'm also going to add you on and I tell you that this one can also be called A complement intersection B complement.
Okay.
Now, can we continue?
Yes, sir.
Yeah.
Yes, sir.
Now I'm going to draw. Now this is where we are going to start now doing the serious work. Serious work is starting. Serious work is starting. I have this set. Now we are bringing in probability. Oh, I've drawn something very small. We are bringing the ideal probability. This is set A, this is set B. How have we called this A? We said A intersection B complement. Since now I'm talking about probability, I will put P, I write like that. Then
Okay.
here I'll put A intersection B. Then here I'll put P. What am I going to write?
A complement intersection B.
Very good. Then I'm going to draw a good set like that. Then what about here outside? We shall put probability of
A complement intersection B complement.
or
A union B complement.
A union B complement. Very good. Then outside here, we are going to have our that everything we add must equal to
Equals to 1.
1. Dear members, I want you to master that diagram. It's going to be a magic for any probability number we are meeting on our way. Now we are going to start deriving. So here up, you are going to allow me also to show you and to let you know that now this is probability of A, then this is probability of B. Now we are going to write the rules. So, and we are going to say that for any event, A and B, number 1, I'm going to shade. When I shade, we write what is there. I'm shading this one. Are you seeing what I've shaded? Green.
Yeah.
That set is probability of what?
Probability.
So
A.
probability of A has this one and has this one. So I write it as probability of A intersection B complement plus probability of A intersection B. Members, are we on the same page?
Yes.
Yes.
Raise up your hand and you tell us, what about probability of B? Let me shade it. Raise up your hand and tell us. Who is ready? Who wants to tell us? Bracing. Probability of B.
Probability of B is equals to probability of A complement intersection B plus probability of A intersection B.
Okay, very good. Thank you, Brace. Now, these are the main ones. Those are the two. Then I want someone who is going to tell us, what about probability of A complement? Probability of A complement. So probability of A complement is what? I think, let me use the complement I've been using to make confuse people. A complement. A complement means what? Anything outside A. That is the meaning. So anyone ready to tell us probability of A complement, or I first share it? Yes? I'm not getting you. Let me shade for you A complement. Now, like A complement means anything outside A. So A is not part. So A complement means anything outside A. So I'll have this. Anything outside A is part. So that's what we call A complement. So can I have someone raise up the hand and you tell us what is A complement? Yes, Cliff.
Probability of A complement intersection B plus probability of A complement intersection B complement.
Okay, good. Okay, that is very good. Then the last one is going to be probability number 4. What about probability of B complement? And we have someone also to tell us probability of B complement. I'm not going to shade it, but I want someone to identify it for us. Apart from Cliff, anyone? Yes, Victor.
Probability B complement is going to be A intersection B complement plus A complement intersection B complement.
Okay, very good. Thank you. Thank you. That is very, very okay. Very, very okay. So in some books, when you find them writing like this, don't say it is wrong. It is the same. Eh? So in some books, you'll find them writing A, union B, everything complement. Eh? They are the same things. So you can choose either to use this or to use that. You will get the same answer. Now, there is the last one. The last one is probability number 5 of A union B. Anyone to tell us what you think? What is probability of A union B? Anyone trying? A union B. Hope you know A union B, where A union B is. Okay, I'm seeing a hand up. Yes, King.
Probability of A union B is P. The probability of A intersection B complement plus probability of A intersection B plus probability of A complement intersection B.
Very good, very good. Now, members, we are going, yes?
Probability of A intersection.
Okay, perfect. Thank you. It is correct. Now, members, I want you to notice and you tell me, what do you think this one? Okay, let me write it here. Probability of A intersection B complement plus probability of A intersection B plus probability of A complement intersection B. Someone to summarize for us, what is this one equaling to in simple terms? Someone who has seen it, what do you think this one I have highlighted? What does it represent? In which simple probability does it bring out?
Probability of A.
Very good. Probability of A plus probability of A complement intersection B. Are we together, members, there?
Yeah.
Now, I want you to look here on number 2. Are you seeing number 2?
Yes.
Is everyone seeing number 2?
Yes.
Yes.
Are you seeing probability of A complement intersection B?
Yes.
Yes.
It is the same that is here, not so?
Yes.
And now I want to remove this one here and I take it this side. Are you getting it? I'm removing this and I am taking it this side. Are you seeing it?
Yes, sir.
Okay, let me come to this page. So I have probability of B is equal to probability of A complement intersection B plus probability of A intersection B. Now, members, I want to remove this one. I bring it this side. But this side, it is positive. So when it comes, it becomes negative. So I'll have probability of B minus probability of A intersection B is equal to probability of A complement intersection B. Is that fine, members?
Yes, sir.
Now, we are going to go back to the other equation. Where we find this, we are going to replace with this. Are we together?
Yes.
Yes, sir.
Now, when I come here, I'm going to write probability of A plus probability of B minus probability of A intersection B. Now, dear members, from today onwards, when you meet probability of A union B, it is the same as probability of A plus probability of B minus probability of A intersection B. Can you take, this is very important.
Yes.
Has everyone understood?
Yes, sir.
Yes, sir.
Okay. Yes, can we first summarize? Can we summarize? When you finish, let me know.
We are done.
Okay. Members, have we finished? Has everyone finished?
Yes, sir.
Yes. Okay. I'm going to assume that now everyone has finished. Yeah, I assume like that.
Yes.
Okay. Okay. I'm going to first give you, okay, that is good. Now we are going to, I'm going to talk about the contagious table. I talk about it, so first try out some numbers. Okay,
Let's try out some numbers.
we
We
first
first
try out.
read some numbers.
Okay, good. Okay, let me now first stop sharing this screen and I share again. Is my screen back?
Yes.
Okay.
Yes, sir.
Okay, can we first try out this one on our own?
Yes.
Okay, first try out this on your own.
What's 320 plus 250?
Have people got the answer already?
Yes. Yes. Okay.
Yeah, members have got the answer? Who wants to take us through how you have obtained your answer? Those asking for the link for ICT, it is there in the chat. Who wants to take us through how we have got the answer? Okay, yes, Blessing.
Yes. So, here we're looking for the probability of choosing a boy, which will be probability of B. And we know that probability is probability of a specific event is equal to the probability of desired events over the probability of sample spaces.
Okay.
So we get the 250 over the 320 plus 250.
Okay.
Yes, which would be, yeah, 250 over 570.
Which you can reduce to. So you can either reduce or you leave it there. There is no problem. So here,
Okay.
one thing you needed to know is to find out the total number of students you have in school. So to find the total number, you add the number of girls plus the number of boys. So which was giving us 570. Now, since we are interested in finding how many boys we have, what's the probability of having a boy? So the probability of having a boy is 25 out of 57. That is the meaning. So in simple terms, it means that so that is the probability, which is approximately 0.4. But here there is no need. You can just stop there. Any questions, or we can continue? Can we continue?
Yep.
Okay. Do you want also to first try this one on your own?
Yes, sir.
Yes.
Okay, let us first try.
Vì đâu sao mà sao rồi?
We are
Kindly
done.
unmute. You are done?
Yes, sir.
Okay. Who's taking us through? Who wants to take us through? Okay. King of spades.
Okay, we know that a coin has two faces, the head and the tail. So to get the sample space, we have to add the head and the tail, that is 1 plus 1.
Yeah. Can you first tell us what do we have in our sample space?
We have a head
Okay.
and a tail.
And a tail. Very good. So what? Okay. So the number of elements in the sample space are how many?
2.
2. Good.
Then the probability of finding a head is
998.
Now we refer to our set. The head is 1.
0
That is 1 over 2.
9 6. No.
Then for the
Yes.
tail, we also refer to our set, and we see that the probability of the tail is also 1 over 2. The tail is 1.
Okay. Very good. Members, are we on the same page?
Yes.
Yes. Okay. Blessing, your hand is up. Do you have a question?
No, sorry.
Okay. Okay. Abdul Karim, are we on the same page?
Yes, sir.
Okay. Do you want to first try this one out on your own again?
Yes, please.
Okay. Let's
Yes,
first try. Okay.
We're finished, sir.
Okay, finished. Has everyone finished?
Yes, we are finished.
Okay, who wants to take us through? Okay, let me Cliff. Sorry. Cliff.
The expected chances of part A are 5 since there are only 5 red pens. Then the sample space is 5 plus 3 plus 7, giving us a total of 15. That's 8 plus
Okay.
7 and 15. So our probability will equal to 5 out of 15, which when I reduce it gives me a third for part A.
Okay.
And then for part B, which I not read, I'll get the 15 total minus the 5 which I read, which gives me 10. So I remain with 10 out of 15, leaving me with a probability which when reduced equaling to 2 out of 3.
Members, do we have those answers?
Yes.
Yes, sir.
Okay.
Yes, sir.
Hope, yes. Hope we are not leaving anyone behind. Is everyone on the same page? Salama, Faith,
Yes.
Joshua, we are on the same page. Eh? Okay. First write the question, then we are going to do this one together. We are going to try it together.
We are done.
Okay. 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 Hope everyone has finished right the question. Okay, now we are going to start. Now, when you find some of these word problems, always they may require you to first draw a set such that you can be able to interpret it very well. So I'm going to first draw my set. In this set of ours, we have two things. I have n of A, which is 15. I have n of B, which is 10. And they are telling us that this set has how many elements? 20. And A intersection B has 7 elements. So this is 7. Now I'm going to ask you, using our mathematics, we know from O level that mathematics. Can everyone first find out How many do we have here and how many do we have here?
8 and 8.
So here we have
8,
8, then here
3.
3. Let's hope everyone is seeing that in order for us to get 3, we have said 10 minus 7, which is 3. For us to get here 8, we are saying 15 minus 7, which is 8. Is that okay to everyone? Now, our next task is to find out what. Oh, paper making. Let me ask Katongole Vian. Katongole Vian, can you mute? Okay. Now, we are going to first find out what about those who don't belong anywhere? These ones outside. Now, let me just put, can we first find, can everyone first try out to find what X is? First find out what you are getting for your X.
2.
2. Are people getting 2?
Yes.
Okay. So how are you getting 2? Can you take us through?
We are adding, we are subtracting the sum of 8 plus 7 plus 3 from the number of the universal plate, which is 20. And
Okay.
the sum of the union of A and B is 20, is 18. Sorry. So you are saying 20 minus 18, which is 20, which is 2.
Okay. Okay. Hope everyone is seeing that. So our X is equal to 2. So outside here, you have 2. Now, the first thing they're asking us to find a probability of A. So I'll come and I say probability of A is equal to, when you get the total number of elements in A. How many members do we have in set A? This set here.
15.
15. So I will say 15 out of
20.
20, which you can reduce to 3 out of
4.
4. Those who want, you can even write the decimal as 0.75. Members, is that fine? Okay. Okay. Can you try to find the rest? Let everyone first try to find out these 3 on your own. First find out and see what you have. So we shall have one person to take us through. You have got what is your part 2, another one to take us through part 3, another one to take us through the last part.
So I'm going to take you through part 2.
Okay, let me first clean the board. Share with us.
Part 2 is saying that they want the probability of A intersection B. Now, probability is equal to the desired chances over that sample space.
Okay.
Then we find out the desired chance, which is A intersection B, and according to the question, it is 7.
Yeah.
So it will be 7 over the sample space of 20.
Thank you. So that is 2. Anyone coming for number 3?
For number 3,
Okay.
we are looking for the probability of A complement, which is everything outside of set of A. And we know that probability is equals to the number of expected chances out of the number of the sample space. And yes, for everything outside A, we have set B only plus
Yeah.
We have set B only plus the probability of A complement intersection B complement. Therefore, we will have the 3 plus 2 over 20. So it'll be 5 over 20, which can be a quarter.
Thank you. So which gives us a quarter. Okay, thank you. Then the last one. Who's coming for the last one? Let's see. Okay, yes. Salama. Salama. Salama, unmute. Salama. Okay, Salama. Oh, sorry. Salama, go on.
Okay, we are going to add the number of A, the probability of A and the probability of B, all plus the A intersection B,
Okay.
which is gonna give us 18.
Okay.
Then the probability of A union B is gonna be it's gonna be 18 over 20. And when you reduce it, it becomes 9 over 10.
Okay, thank you.
Welcome.
Okay, are we there, members?
Yes, sir.
Okay, okay, okay. Are we good to continue?
Yes, sir.
Yes,
Okay.
we are.
Okay. Now we are going to apply now some rules. You remember the rules we have been looking at?
Yes, sir.
Okay. Let us first apply them. For number one, first try. Okay, let me hope everyone is trying. I want you to look at the rules we have talked about of A union B. Let's go back. Yes, I'm going to share that rule. Let me share it such that members can. What is that thing? So this is the one we are using. This one here. So look at it very well and ask yourself, Members, have we tried?
Yes, sir.
Yes.
Yes,
Okay.
Yes.
Have you finished or you are completing?
we have finished.
Okay. Has everyone finished?
Yes.
Okay. Good, good, good. Okay. I'm going to, okay. Oh. Which answer do you have?
For part A, I have 5 out of 8.
5 over 8.
5. Do we have everyone? We have that?
Yes.
Yes, 5 out of 8.
Perfect.
For
So
part
those who have
B,
just,
for part B, I have 3 over 8.
3 out of 8 and the rest?
The same.
The same. Okay. So who's taking us through here? Anyone who has not said anything and you want to take us through? Okay, King of Spades.
Okay, so for part A, like according to the rule of the probability of A union B is equal to the probability of A plus probability of B minus the probability of A intersection B. Now for the probability of A here, we have 2 over 8 plus the probability of B, which is 4 over 8 minus the probability of A intersection B, which is 1 over 8. So if we go with board mass addition first, so we add 2 over 8 plus 4 over 8, which is 6 over 8, minus 1 over 8, which is 5 over 8.
Yeah, thank you. Who's taking us through part B? Part B. Anyone? Abdul Karim? Who is ready for part B? Okay, I'm seeing a hand up. Okay, now apart from King, I want to know how you have got the 3 out of 8. Okay, King, you can tell us.
Okay, so since if we are to see here the universal set maybe out of 8. So to get the probability of A union B complement, we will say that 8 over 8 minus 5 over 8.
Okay.
Which is 3 over 8.
Okay. Okay, good. Okay, now let me add something. Now when it comes to, yes, I'm coming. I'm going. So you remember very well, I told you that probability of A plus probability of A complement, we said is equal to what?
It's equal to 1.
1. Very good. So whenever you get probability of an event plus its complement, you must always get a 1. It also applies when you have probability of A union B plus probability of A union B complement. Who can tell us what do you think this one is going to equal to?
1.
1.
1.
So in order for you to get this one, A union B complement, you just say A union B complement is equal to, so you remove this one and you take it 1 minus probability of A union B. Is that okay?
Yes, sir.
Yes,
Who
sir.
can now tell us A intersection B plus probability of A intersection B complement? What is it equal to?
1.
1.
1 minus.
Is that okay? So in case you want probability of A intersection B complement, what will it equal to?
It will be 1
minus
minus probability of A
probability of
intersection.
A intersection B.
Very good. So we are adding on the roots. Is that okay?
Yeah.
Yes.
Now let me also add you. When you find probability of A union B, we say that by definition is probability of A plus probability of minus A intersection B. Not so? Is that okay?
Yes.
So when you find something like this, A complement union B complement, what you do also here, when you look at the first equation, there was no complement anywhere. So when they put complement on A and B, also go on putting complement everywhere. Is that okay?
Yes, sir.
So we shall have probability of A complement plus probability of B complement minus A complement intersection B complement. Are we together on that?
Yes, sir.
Yeah.
Excuse me, teacher.
Yes.
Teacher, may you please repeat the explanation?
Which one?
May you please repeat the last explanation?
Oh, for this one, eh?
Yes.
Okay. We are saying these ones, we call them the De Morgan's rules. Eh? When I have probability of A union B, we know that this is the same as probability of A plus probability of B minus probability of A intersection B. Now, if it happens that your union, they have put a complement and a complement, or at times when they don't write it like that, they write it like A complement union B complement. So once you find that they have put a complement, do not struggle. As long as it is a union, go on all the digits, on all the invents you have, also you put a complement. So I will just say A complement plus B complement minus B A complement intersection B complement. Is that quite fine?
Yes, sir.
Okay.
Yes, teacher.
Okay. So, but please don't forget, you can also put this note somewhere that when you have A union B complement is the same as probability of A complement intersection B complement. Those two things are the same. Is that fine?
Yes.
Similarly, when you have probability of A intersection B complement, this one is the same as, anyone who can tell us what you think? I want you to relate. In case this was union, this was intersection. So who can tell us what you think this side is going to equal to?
A complement.
A complement.
Intersection.
Look at the signs, how they have changed for the first one. Also here now.
Union B
A
complement.
union B complement.
Very good. Yes. Are we together on those rules? Are we
Could you
together?
repeat the last explanation, please?
The last one, eh?
Yes.
Now, this last one these are what we call the De Morgan's rules. Now, when you know very well that probability of A union B prime is the same as A complement intersection B complement. Now, when I come, when I'm going to show you probability of A intersection B complement, it means when I come to the Venn diagram, this is A and this is B. So A intersection B complement, it means anything outside A intersection B. So anything outside is this. So anything I'm shading is what is it? Outside the intersection. So that is the region. So that one is the same as having probability of A complement union B complement. Are you getting it? So when they tell us A complement union B complement, when I'm shading it, I'm going to come. So A complement union B complement. I'll have my A, this is B. This is A and this is B. So when I'm shading A complement means anything outside A. So I will shade this. I will shade, I will shade, I will shade, I will shade like that. Now, when I'm shading B complement means anything outside B. So I will come, I will shade like that, like that, like that, anything outside B, like that, anything outside B, I shade like that. Are you noticing?
Yes.
Yes. So you are noticing that this region that has been left, it is the same region like saying A intersection B complement.
Yes.
Have you understood?
Okay. Thank you, sir. Yes, sir.
Okay. Okay. So have we finished writing these rules? So let's summarize them somewhere. Have we finished to summarize?
Yes, sir.
You let me know when you finish.